working on hardware, so we're ready to go. Welcome to the first 2013 Bay Area Search Meetup. We've got a couple things going on tonight, actually. First, Greg is going to start. He's the CTO of Bleco, and he's going to, there's a search data competition coming up, and Greg is organizing the data, and it's going to be hosted at LinkedIn. He's going to tell us about that, and then do a quick demo of a new mobile app. And then we're going to move on to Mark from SurfCanyon, who's the main speaker tonight, and he's going to talk for a little less than an hour with Q, and then plus Q&A. The stage is all yours. You can have the time you need. So you guys can go ahead and get all your hard questions ready. You can go look on the, use the Wi-Fi, go look on the SurfCanyon site, and if there's things you think aren't quite right yet, you get ready for it. Anyway, so that's the lineup for today. I'd like to start out with announcements. So my first announcement always is I'm always looking for future speakers. So if you have suggestions for future speakers, you can post them on the Bay Area Search Meetup page, or you can tell me in person, or you can send me an email. So that's the number one thing, is lining up speakers. That's what I always need help with. And then I always say, if anybody wants to volunteer to help do video and video editing, let me know. But it's been a year now and nobody's volunteered yet. So it seems like it's going to be a little bit of a moot point, that announcement. But I'm not real enthusiastic about video. So if somebody wants to do it, I'm more than happy to accept. And then any other announcements? If anybody is looking for a job, wants to announce a similar meetup, now is your chance. Anybody want to say anything? No? Okay. Well, I work at eBay. We're always hiring. So if you're looking for a job, there's flyers back by the door. And you can come work here permanently, and then you can do video.
My name is Sanjeev. This is my first Bay Area Search Meetup. I used to be at Autonomy, and prior to that, Iron Mountain and Stratify. And currently looking for opportunities to work. My background is in running operations for search kind of stuff. So if there's anybody here who's got openings and such, I'm happy to talk to them.
I'll hit you up in a minute. eBay just built a new search engine public. You can look on the web. It's kind of a big project. So it's still going on. Anybody else? No? Okay, great. Well, welcome to Greg, and the stage is all yours.
Okay, so first things first. I've been working on this for a while, and it can almost be announced a meetup that's aimed at open and big data, and it's going to have a lot of search stuff involved with it, which is why it's worth mentioning to you guys. It will be hopefully in late March at LinkedIn. It will be 24 hours, and sort of the unique thing about it is that we're going to be providing data sets. So most most hackathons that involve big data, you're supposed to bring your own data and somehow have the processing power to process it, and that sucks because a lot of people don't. If you want to get your feet wet with big data, you can't really go to that hackathon and do it. So our goal with this hackathon is that we're going to provide data sets, and we're going to provide enough AWS time to do something real during that 24 hours. So examples of the data sets will be the Common Crawl, which is a foundation that has a crawl with 5 billion web pages in it. They also have an URL index that they just released that's available for random access. So for example, if you want to data mine one website out of those 5 billion web pages, you can do it efficiently and then do something with that website. So for example, if you wanted to experiment with site search, you can data mine wikipedia.org out of it and then you go process it. Another thing is, Bleco donated search ranking information to Common Crawl. And so you can go look for the Common Crawl pages and see what Bleco thinks their rank are, whether we think they're spam or porn. There's going to be so those are both metadata data sets that are small. They're only about a terabyte each, whereas the crawl is a lot. And some other data sets that we hope to have, so the Internet Archive is involved, and they have an audio data set which is quite large. It also has metadata that you could conceivably work with. And so those are the ideas for the data sets. And then as far as processing goes, we're going to have short little classes on AWS and using Hadoop with AWS. And so, for example, the common crawl has a machine image which is already set up with a full Hadoop everything, and it's set. If you want to go, grep through the common crawl data to find, some string, it's a very straightforward thing to set up and run. And that's about $70 worth of AWS time, which will be given away free. Question?
Yeah, can you use web instead of
so you'll be able to use whatever you want. The AWS time is just dollars, and you can install whatever image you want. So if you're comfortable with something else, you are more than welcome to go do something with it. The goal is to enable people to do whatever it is they're interested in. So very, very open-minded sort of thing.
Is this a competition, you said?
Well, so there are going to be some prizes and things. But it's sort of the usual hackathon thing that it lasts for 24 hours. But if you're old like me, you'll go home and sleep. And we'll give away some prizes at the end. But if you care about prizes, you can care about prizes. If you don't care about prizes, that's fine too.
There's always bragging rights, though.
Yeah.
Yeah.
Yeah. And actually, I'm gonna award the prize for the coolest hack because I could care less about commercial value or any of that kind of stuff. Just something that blows me away. That's what I like out of that personally. Okay. So it will be announced by Brian when we actually finish settling, which will be about a month before. So they're renovating the area and all this kind of crap. So hopefully end of March. And when we make the announcement, we'll also hopefully announce all the data sets, so you'll be able to go sort of get a look at what they look like and get your software in order if you want to use something that's not something that we're providing. You want to get your ducks in a row before you show up. Okay, so that's the first thing. Second thing is, so I was so amused when I looked at the meetup, and I'm like, wow, there's a guy who's actually talking about doing something different in web search, because web search sucks, and web search even sucks for my own damn search engine. So we have the search engine, right? And so you search for Martin Luther King, and you know what? The answer is basically 10 blue links, and I hate 10 blue links because we know a lot more than 10 blue links about Martin Luther King Jr., but this is all we'll show you. It's sort of the tyranny of the interface. If you A/B test, you'll discover that people insist that the links be blue, right? And so we wanted to do something that was completely different, and so the thing we did that was completely different is a tablet search engine, which I wish I could demonstrate on a tablet, because it's kind of clunky when it's in this interface. Okay, so it's a tablet search engine, so it swipes left and right, and here's the first page, and so here we are, and somewhere here on the end is Martin Luther King. So Bleco has a lot of stuff inside, and we actually classify the query. So if you type in, cure for headaches, we know that's a health query, and the results you get are going to be sort of 100% Western medicine. But if you type in cure for headaches aromatherapy, we also have aromatherapy results. So what are these? These are things we call slash tags. They're human curated lists, and we have 2,000 of them. And nobody, on Bleco.com, nobody knows how to use them. Nobody sees it when we tell you that we're using them.
The stupid thing, on your main search on Bleco, there is no link to Isaac with the search that I already entered in Bleco.
So it's true. However, if you're on a desktop, it sucks. So it's not that useful to provide that link in general. Most of our users are desktop users, and this interface right now is only available for tablets. We're doing a phone interface, and desktop comes third. So it's not ready yet. Okay, so we know a lot of things about Martin Luther King. We actually know that he's relevant to our African American slash tag, our Black history slash tag. There are social results for people named Martin Luther King. He's an important figure in American history, and there's also enough people who are involved in, there's enough schools named Martin Luther King Jr. School, this and that, and enough libraries named Martin Luther King, this and that, that there's a lot of results for those, and there's also lots of conspiracy theories about his death. So in this interface, we actually show this to you. So if you go up and down, which I can do this on this damn laptop, it's easier said than done.
It's an app you can download on your Android.
Yeah, here we go. Yeah, so it's available for both iOS tablets and Android tablets. And so here I am going up and down. So up and down is by the categories. And then when I go side by side, it's by, which I have to click for, that's moving within a category and showing the results. So instead of 10 blue links, we've got more than 100 links on this page. And when it's appropriate, they actually have images. And you can also, there's a summary line on the bottom. So for example, if you're interested, wow, I didn't realize that there were conspiracy theories about Martin Luther King's just like JFK, you can click on this and you can find out something about the conspiracy theories involving his death. So it's completely different from 10 blue links, and you should go try it. Apple actually has been promoting us since the moment we put this into the store. So they really love it, and we hope that the phone and desktop versions of this, when we get around to them, are going to be awesome too. So that's all I have.
Can you make the Windows 8 version?
So indeed, the most number of requests we have for people who want a Windows 8 version, 0.08% of our traffic is Windows 8, but we're going to ship it anyway. So yes. Okay, and let me give you a little introduction actually to the next speaker. So we're a search engine, and we talk to a lot of people about search engine stuff, right? So there's this other alternative search engine called DuckDuckGo, and we trade data with them. And so we were talking to Mozilla one day, and we're talking, it'd be really neat if we could only figure out something cool that would go viral, that would be some awesome plugin from Firefox. And you know what the Mozilla people said? They said, look at what SurfCanyon is doing. Those people have their act together. So that's your intro.
Thank you. Okay, we're set. Thank you, Mark.
Thank you.
Thank you.
Well, thank you for the very flattering introduction. Appreciate that. Unexpected. Appreciate it. And thank you, Brian, for inviting me to talk. And obviously, thanks everyone for showing up. I don't know how many people have actually heard of SurfCanyon or not. They've actually been around for a while. And I'm looking at this screen wondering what I clicked to go to that.
You just hit the space bar or the arrow.
Oh, just the space bar? Okay, there you go. Okay, great, thank you. I'd like to say we're going to talk about a new search technology, but given that we've been doing this for coming up to 7 years, it's not actually that new, but it might be new to you. I think it's something that eventually people are going to be seeing a lot more of. And it's referred to as dynamic ranked retrieval, which effectively means that we are taking the traditional static search page with the 10 blue links and transforming it into a fluid search experience where the results move and adjust in response to the real-time inputs of the user, which effectively means the clicks and other sorts of activity that occurs on the search result page. So I'll start off by saying what it is not, and because that's often very helpful when I start presenting what it is that we do. It's not personalization in the sense that we don't have histories of what people do. We don't build a profile of things that you like and things that you don't like. If you do a search for pizza and you click on pepperoni, we don't save that so that the next time you do a search for pizza, this person likes pepperoni, right? That's not what we do. What we do is a form of personalization that is session-based, it's information session-based, so we have query boundary detection that will span multiple queries, but for the most part, it's during a certain information session that the user is conducting on the search engine. We'll build a real-time profile of their intent based not only on the queries, but on the activities that occur on the search page. And we will re-rank the results on the fly. So typical personalization that people are probably familiar with on Google, where it's building a long-term profile of your history and understanding who you are and what you like in general, will modestly adjust results, typically further down on the first page, because when we might know that someone is a fan of music, but when they do a particular search, we might not that might not be what they're looking for at that particular time. So you can only make modest adjustments. Whereas what we're doing, since we're using the immediate signals that are coming off the search page, we can make grammatic adjustments to the search results. We can re-rank them grammatically on the fly, and I'll be giving you some examples of that. So a few of the things that that I'll point out here, when we started the company, one of our philosophies was to not. So the first philosophy was that all of the signals need to be implicit. So explicit signals can be very handy, but we decided not to go down that route because for a couple reasons. One is the onus on the user. A lot of people don't like giving explicit signals, and the other reason is that even when they do, they often give misleading signals. So we wanted to build an engine that was driven purely off implicit signals. And we also wanted the experience to fit in smoothly and seamlessly with the search experience that people are already familiar with. I think it's fantastic that other people are expanding beyond the 10 blue links, and I think it's fantastic what Bleco is doing. When we started SurfCanyon, though, we decided that we were going to fit into that model and make it so that we didn't have to teach people to modify their behaviors. So, and the last thing is, when we started this company, I really didn't think we'd actually. We filed the patents when we started, and I thought there's no way we're going to be around when they actually issue. And yet here we are, and they issued, and so that was an exciting moment for us. Anyway, all right, let's get to it. So I'm not going to talk too much about the opportunity. Greg colorfully described the problem with search today. We concur. In the abstract of this talk, I mentioned that search is stuck, and it has been for a long time. Certainly there's been a lot of interesting innovations with respect to not only personalization, but incorporating different types of media into search and understanding user intent and all that sort of thing. But for the most part, the search page has been stuck. And when I said search is stuck, what I meant was the page is static. And it continues to be static. Pretty much every search engine that you look at, you enter the query, the results are rendered, and no matter what you do from that point forward, that page, that's a static page. My favorite quote, it's an old one, but I love bringing it up. Stephen White's over thing. What's popular feature in search is back, but I just happen to like that. I think it's funny. And it's kind of true. This is, I think we're sharing this presentation. This basically means people love us. So,
And that's not a word, right?
No,
They still love you.
They still love us. That's a very good point. Thank you for pointing that out. I don't know if people are familiar with Thorsten. We actually have a paper that was published by SIG-IR, and the reason I'm bringing this up is because the paper was unique in that a lot of times when people do research, particularly academic research on search, they work with labeled data. They do NDCG analysis, precision at 10, all that kind of stuff. Our paper used actually real-world users with real-world data running queries on Google. So I'm going to get to that. So this is how it works, and this is the most important slide of this talk. So I'm going to take a few minutes to go through it and just really hammer home what it is that is actually happening. When you run a query on a search engine, Google, Bing, Yahoo, eBay, you're presented with a list of results. And for the most part, that list is ordered in a descending probability of being relevant to the user. So that whatever result you think is going to be the most relevant to the user, that's going to be number one. The second result is going to be whatever result you think is the second most likely to be relevant to the user, and on down the list. Now, obviously, you can make modifications for diversification. Certainly, people understand that. You might want to move a few around just to mix it up in case you got it wrong. But generally, this is what happens. Then let's assume a scenario where the person conducting this search looks at the page, clicks on result number 5. And what's interesting is that when you click on a result number 5, really what that searcher is saying at that moment is that result number 1 wasn't the most relevant, or 2 or 3 or 4, but 5. So if the search engine would have known a priori that this user was going to click on number 5, the search engine would have made it number 1, obviously, right? Because that's the one the user wants. Now, if you're going to make search result number 5 to be result number 1, in other words, the most relevant, obviously 1 through 4 are going to be less relevant. And what you end up having is a number of other results that are similar to result number 5. Obviously, are going to be more relevant to the user. You would have generally assumed that. And the results that are dissimilar from number 5 are going to be less relevant. So the search engine would have shown a completely different search page if it would have known that the user is going to click on number 5. And that makes sense. You already have questions? Go for it.
That implies that you have an implicit assumption in there that the user has seen a summary of the page at the time of the results being served.
The result page consists of titles and snippets.
Similar to what we previously see.
Yes. Yes.
Okay. So if the user had already previously in another session had seen 1 and now coming to a second session as you call it,
Well, if it's
clicking 4 and said I already saw 1, I need to click 4 or 5.
So I think what you're implying is that those results number 1 through 4 might have been the most relevant to that user in a previous session.
Yes.
But in this session is number 5.
This session is not so bad.
So there you go. The other session's the past. It's
Fancy.
history. We're moving forward. We're going to the next search, and it's number 5 is the one. If you show a search page with results 1 through 10, no matter what happened previously or what the user's done or looked at, if the first action is to click on number 5 is the top result.
Are you looking at the document similarity vector to figure out what are the similar documents for this number 5?
I thought my guess is it would be less than 10 minutes before someone asked about our feature set. And I was right. You already asked. So the re-ranking is naturally algorithmic based. We use a very large feature set, which includes features of both the documents, the user, the result set. So we look at a lot of different things. Yeah.
You don't have enough information about the user for such correlation. Right?
We know they click number 5.
That's just one.
That is the most important thing to know about the user is they click result number 5. Everything else is of lesser importance. The signals that a user gives to a search engine, it is our belief, have very short half-lives. So it's great that you can build profiles of users long-term, and you can see generally this person likes pizza, generally they like sports, whatever, and that's very handy. But there's nothing more useful than the immediate signal that you get from the user, and the half-life of that signal is not measured in months or days, or even maybe hours, depending on the query. It's measured in minutes and seconds.
It's
So in the same session, if the user comes back and clicks on 1, you would re-rank again.
Yeah, well, I'll show you that later. We're going to do that.
You mentioned this half-life thing in the abstract as well. Did you measure it, and if you did, how?
Did I mention half-life in the abstract?
Yeah, I saw it online.
Yes.
I did?
Yeah.
Well, that was very clever of me to do that. No, we have not measured it, but I do talk about it in the abstract.
So it's
So
just a
it is-
qualitative statement you're making.
Yes, exactly, right.
How are you going to present the new results? I would get irked if you.
We're going
gave a
to
range
get to that, so
on
thank
the
you for
fly.
asking.
I don't
So,
think I'd like that.
well, maybe it's not for you, but we'll find out. So I'm about to show you exactly how it works.
Okay.
Can I give an example to back up what I think you're going to say next? Is on eBay, if you search for basketball today, we show you what most people do. So we'll show you, if there's 100 results on the page, we're going to show you 98 basketball shoes, because that's what most people buy after they type basketball. And we're going to show you 2 basketballs. And if you click on both of those basketballs and hit the next page, what do you think you get on the next page? 98 more shoes and 2 more basketballs. And if you scroll down, you click on both of those basketballs and nothing else, and you go to the third page, what do you think you get? 98 more shoes and 2 more basketballs, right?
Thank you.
It doesn't
Brian. I
change.
appreciate that. Yes, it is static, and what we're doing
And
is
that's what most people do.
we're developing a fluid search interface, and I'm going to demonstrate it for you here in a few slides, and then we're going to try a live demo. So cross someone goes to a popular search engine and they do a search for digital cameras, and naturally the user is going to be presented with some results that are shopping, commerce related. There's Wikipedia is the first result, so that's often the case. But after Wikipedia, you've got shopping and you have reviews. And over here on the right, what you've got are the ads, and the ads are typically commerce related, because that's what advertisers do, right? We have 67 million results. That's a very large result set. So let's assume that the user decides, you know what, I'm going to click result number 3. And we can infer from this, since that's a result related to reviews, and it's after a result related to shopping and before other results related to shopping, that perhaps this user is interested in some digital camera reviews. This user will go to PC Mag, consume that information, and should he or she then return to the result page, what he or she is presented with is the page that looks like this. So the first 3 results are the same, and this one was result number 4. And what you have here is still the 67 million results. What you have here are, these are the dynamic results. These are the ones that were re-ranked on the fly. And the algorithm that we've developed goes to look at pages 2 through 10, 20, theoretically 100, but generally up to page 30. Finds other results that are related to what we have deemed to be the intent of this user, like right now at this second, which is reviews, and brings them forward to page 1. So this is a review that was originally on page 4, and this is a review that was originally on page 2. Give you 1 second.
Yeah, so.
And in 1 second. And simultaneously, if the user is interested in reviews, we actually have never done this. This bit was Photoshopped. But theoretically, you could also replace the ads. Why show commerce ads for selling? Here's a camera for 95% off. I'm not buying them. I'm reviewing. Put some ads related to reviews.
So are you trying to predict the next intent of the user? Because this action, I wanted to review a digital camera. The user might be done with it. The next action may be totally unrelated to the previous action. It's something in the workflow. I wanted to see the review to be able to buy 1 camera.
I think this gentleman up here would like to answer that question. In this particular information session, the user is looking for reviews. It is entirely possible that in the given search, without changing the query, the user might change intent. So my first click, I want reviews. I read a review at PC Mag, and all of a sudden I'm ready to buy. So I click back, and boom, I'm going to Amazon. Possible, perhaps unlikely. But even if that were the case, we actually can handle that.
Unless of course you come back to that search page and give a new query saying digital
Right.
cameras
You can always
purchase.
Right. You can always issue a new query and continue forward.
In the same session.
Right. Yes. And we have the ability to recognize and account for what we refer to as topic drift, which is your original topic was this, or context drift, and then as you're continuing your search, you learn, you change, you modify your behavior. As Brian pointed out, with his basketball example, we actually handle this. So in that search that just happened, the user search for digital cameras, click some reviews, they're looking for reviews. The user then goes to page 2, and what we present the user with is a page 2 that consists entirely of digital camera reviews. So this is page 2, and here they all are, and the entire second page is re-ranked on the fly. So as soon as the user clicks next, we calculate it based on not only the query, but the intent model that we built on the fly, and we have results from page 6, 16, 4, 7, 4. The 2 there that don't have front pages next to them, those were originally on page 2, but they're all related to reviews.
So is there any reason why you choose for your relevancy ranking, why you choose up to 100 and not say up to 1 million, because 67 of them are presented to you?
So as a technical matter, you can't go past page 100 on Google. So just give it a go one day. Just
1,000 results the next.
Yeah.
Sorry, 1,000 results the next.
1,000 results, 100 pages.
Yeah.
Right, 10 per page, right, exactly. 1,000 results, that's the most that you can get. Okay. So, the first rule of a live demo, never do a live demo. So we're going to do one now. All right.
So if you search for what I found that doesn't work on the
I beg your pardon?
remember that I asked you to enter 5 projects?
All right, we're going to do a search that I'm going to be able to explain to everyone in the room. So we can do that one maybe later or offline, but we're going to do this search. And this search, people who are familiar with IR probably familiar with searches for things like dolphins, jaguar, bear, and they're often used to demonstrate just a problem with disambiguation. No matter what you know about that person, when they do a search for Java, they could be looking for the coffee. Even if it's a programmer, someone in this room actually could do a search for Java and be looking for coffee. Chances are slim, but it's possible. So you actually never know. When someone does a search for dolphins, are they looking for the animal? Are they looking for the football team?
There's a browser.
The browser, yeah, good luck finding that. But yeah, there's a dolphin. There's a browser called Dolphin as well. But perhaps if we look at this page, so this is Google, another popular search engine you all might be familiar with. And as you can see, the first result is the animal, then the football team, the animal, football team, and so on. If I were to click one of these results, let's say I click the football team, this page comes up, I consume this information, I'm like, oh great, I love that. I go back, and obviously nothing has changed because it's static, which is my whole point. So this is the point in the demonstration where I start installing software on Brian's computer.
On my computer.
Yeah. So you can
Go for it.
You can thank me later. So you can go to SurfCanyon.com.
I'm embarrassed that it's not already there. No.
It would have messed up what I just did, but that's fine. There's a big link right in the middle. We'll bring you to this page, and you can say, you know what? I want to unleash the power of search. So I'm just going to install this, and there it is. And half a dozen clicks later. Okay, it's installed. Happy day. Okay. All right. So let's do that query. In fact, it's right there. Oh. I'm going to change one thing just to make. You know what? If I do a control click, it'll open in a new window, correct?
Probably
Is it command click? Yeah, command click.
I think it's Firefox.
It just makes it easier to actually see what happens because it's exciting and you don't want to miss it. So let's do the same thing that we just did. Same query for dog. We're interested in the football team. So I'm going to come here. I'm going to do command click just so you can see it happen. So this is the web page, same as before, opens up. But what SurfCanyon has done here is we've decided, just like I showed you in that previous demonstration, digital camera said, okay, person wants football. So we found results from page 3, 2, and 2 related to football. We just brought them right there to page 1. Previously, when we ran the query, there were only 2 results related to football on the first page. Well, now there are those 2, they're still there, and 3 more, so that's 5. And let's say I'm looking at this, and I decide, the schedule. All right, that's what I'm interested in right there. You click on that, and we fetch another result. This one's from page 3. And this result is, another football-related result. We'll nest them 3 deep. The number of re-ranked results, these are re-ranked results that we'll bring forward, is actually a setting the user can adjust. Generally set at 3, and we'll bring up to 3 results forward depending on our calculations of the relevance of these results compared to what else is on the page.
It didn't seem to do a query to the engine. Was it from the cache?
So in the background, our application fetched the first 200 results. So fetched the first 20 pages. And and is looking at those, or I think it's 100. Maybe the first 100 results is looking at those when you make an action. Re-ranks the first 100 results, then brings forward these. And I mentioned previously that it can go as deep as take 100, so generally the way it works to save on computation power and so forth. We'll go fetch chunks of 100 results, depending on how many actions the user takes. So no reason to go fetch 1,000 out of the gate, fetch 100, and then after 3 or 4 actions, we'll fetch another 100 results. So there was a question of that. Yeah.
So when you say that you fetch those 100 documents, were you fetching the link and the snippet, or were you?
Yes.
Yeah. Okay. You're not looking at the entire document. You're just looking at the snippets, the summary that you represent.
In general, yes. Although document content is an important part of the process.
What percentage of queries are you addressing? Like, what percentage of queries do you think can potentially benefit from this dynamic ranking?
I'll get to that later. Actually, yeah, I've got a slide on that. So,
But can you, that was a good question. I mean, are you fetching the pages and looking at the content and ranking them what?
that would be,
Really difficult.
we'd look at, it would take a lot of bandwidth. We definitely look at document features. We don't fetch every document. We would pull down the internet and so forth. But yeah, we make some smart decisions based on title snippets, URLs, and we do look at document content on some occasions.
So when you are fetching the results, will the query will still be dolphin, or it will be
Yes.
dolphin, football, something like that?
Yep, awesome.
But if you are doing a search with dolphin football team, then you are going to get much more relevant results, right?
We don't rewrite the query.
I'm just wondering, like,
Because-
assuming you leverage that feature, then the results that you're going to get from the search engine is going to be much more relevant than.
No, not necessarily. You do a query for Dolphins, there are results related to the football team. They're already in there. In fact, if we saw there's 2 on their first page, and I brought forward 3 recommendations and brought forward 2 more. If I go to page 2, here's the page 2. It's entirely football.
I think a different version of that question would be, do you present results which are not in that 100 pages?
We
No.
can, it's possible. But it depends on the situation.
So
Generally, we don't rewrite the query, but we can rewrite the query. In situations where the result set is exhausted for a particular topic, like if you do a search for Java, and you're looking, here's a better example. You do a search for Dolphins, you're looking for the browser. In the top 1,000 results, maybe the browser's in there 2, 3, 4 times. I've never actually looked. At that point, you might actually need to rewrite the query, Dolphin browser. I'm going to continue with this example. I'll take some more questions later. Okay. Because I'm about to amaze you with something. So I'm glad everyone's sitting down. Okay, so here you see that all these results are related to football. Okay, so I'm gonna clear this out, and we're gonna do it again. Does F5 reload the page?
Command R.
Command R.
Command R? Thank you. Here we go. People tell me don't use the Mac. All right. My wife uses the Mac. All right, so here we go. Same query. I just reset our engine. Well, this time let's do the animal. I'm not going to spend a huge amount of time on this. Command click. All right, clicked on the first result. Get 2 more results related to the animal. And let's say we come down here and we're looking at, here's another animal result. Brings forward some facts about dolphins. Bottlenose dolphins are interested in that. Secret language of dolphins. It's behaving as you might expect. Go to page 2. The entire page 2 is related to dolphins. This is the exact same query. And I click next. In the first case, football. Next, this case, the animal.
But you reset the session.
No, I just reset our engine. It's the same query. I mean, you saw me run the query for dolphins, and I click football results, and I have football. So, and I'll show you one last thing. So let's say we talked about changing the topic. I was looking for reviews. Now I want to buy. Okay, so let's say I'm not going to reset anything, but I'm going to go to the top. I'm going to say, you know what? Actually, I'm wrong. I don't want the animal. I want football. So I'm going to do the same thing I did previously. Got some more Miami Dolphins football results. There was another one here, wasn't there? Here's football. There's football. There's another football result. So I'm going to do a few of those. Now, page 2, as you remember, it's all the animal. So let's see what page 3 looks like. It's all football.
I like that. I think that's a better thing.
Everyone can hold your applause to the end. All right, so that's it for the demo. I was begging for that, so it's.
I got a question for you.
It's on the screen now.
Okay. Oh, there we go. Okay. Hold on 1 second. The browser has launched the video. I think it should be a rule. No website should launch videos.
You know, we tried to use that, but unfortunately the JavaScript that you have to figure out in order to figure out if there's a goddamn video or if it plays music is too complicated. We were going to break those websites down.
You bring up a website and all of a sudden it launches into whatever. Okay, so the only thing so this is just a brief slide to show kind of how we've been doing. The folks at Mozilla, obviously we're very flattering, so we appreciate that. We've been growing. We've been doing this for quite some time. We've processed 6 billion queries to date, so we've had a lot of data that we've been able to work with. And in May of 11, we surpassed the 10 million queries a day. So I think more interesting, though, is going to be talk about what all this data actually says about search, the results, relevance, re-ranking, you name it. This is a graph which probably everyone in this room is familiar with. Actually, I think this is AOL's data. I'm not positive though. But generally, when you for any search engine, the click frequency is going to be of the results is very tightly correlated with the position of the result. The result number 1 on any search engine, that one gets clicked the most, and so on down. And by the time you get to results, this is a log graph, as you can see. Results number 2 are clicked less than frequently in 3 and 4. By the time you get to 9 and 10, you can actually see the breakpoints. See on the far left there? You can see the breakpoint. You can see a breakpoint between the first result, number 2, obviously large, and between 10 and 11, you can see a breakpoint, and then the rest, it kind of just slopes down, because most people don't go to page 2. Certainly they go to page 3, 4, and here goes to page 20. Raise your hand if you've gone to page 20 of a search. What? Oh, now that you count. Okay. All right. So
often on search engines.
So one of the questions is, if it's on page 20, maybe it's there for a reason, because it's terrible, right? Maybe when I do a search and I get 67 million results, 10 are good and 66,999,990 are terrible, right? So one of the things that we looked at was, well, when we actually do the re-ranking and we take those results from pages 2 through 20 and we bring them to page 1 or 2 or whichever page the user happens to be on that time, at what rate are those results clicked? And is there any correlation between where the result initially comes from? This is the initial rank of the result and the rate at which it's clicked. And as you can see from this graph, well, if there is a relationship, it's a very weak one, which basically means that when we're bringing results from page 16, 17, 20, they're going to be clicked with approximately the same frequency as the ones on page 2, 3, 4, 5. So what this graph is saying is that if you do the re-ranking right, there is actually really good stuff that's not on page 1 that is relevant to the user. We took a look at, well, what happens if we just, maybe people are clicking these results just because they're there, which is certainly there's a lot of position bias, and if you put results on a search page, if you put a result at number 1 on any search page, it will get clicked, right? Because people just reflexively click result number 1. But here we take a look at, if we were to just randomly grab results and rank them up, as opposed to algorithmically determining which results based on our real-time model of whatever we refer the user's intent to be at that time, there's actually quite a big gap. So the rate at which the results clicked is double, which means that you when you do you can't just grab any result that's buried. You have to pick the right ones. And that's why we're able to get the lift between the red dots and the black triangles. And then, so the next question people typically ask, okay, great, you're moving all these results around. How good is it? I mean, does it actually help people find stuff faster? That's a very difficult question to answer because fundamentally what we're doing is we're changing the UI. It's kind of unfair to compare a search result set with 10 results to one that has now 13 results on it and compare, okay, which one is helping you. So we look at the click rates of the different results as a proxy for the relevancies, but what we really want to do is compare apples to apples. Now, you can do a page one study with labeled data if you want to do NDCG or map type analysis and do some computations. And actually, Torsten's team actually wrote a paper about that, which is linked on our blog if you want to read it, where they go through the labeled data using something similar to this, computing improvements in NDCG. So one of the tests that we did was to look at page 2. As I mentioned previously, it's rare for people to go to page 2. It happens in approximately 12 to 14% of the queries that we witness in our system. But what it does provide is a very clean opportunity to compare apples to apples. Because in the control case, we can show results 11 through 20 as originally computed at the moment the user pressed search, compared to the re-rank set of results, which I showed you earlier. It's either a page of digital camera reviews, or football, or the animal, or whatever. Here's a graph which demonstrates the rate at which the likelihood of the page 2 generating a click in the control versus the test as a function of the number of actions a user takes on page 1. And I spent a little bit of time talking about this one because I think it is interesting. So at the far left there, these are the users who run a query, and all this is on Google. They run a query on Google. They look at the top 10 results, and they select none of them. And then they click, I'm going to page 2. And what we did here is we showed that by presenting a re-ranked page 2, or effectively we use the top 10 results as negative signals, we're able to increase the likelihood of the user selecting a result on page 2 by 38%, which is actually pretty huge. What's interesting about this is that the next point here, this is when the user makes one selection on page 1 and then goes to page 2, and the number drops, which is a little bit counterintuitive. Because you would think that if the user was on page 1 and they selected a result, not only do we have negative signals, we also have positive signal to help with our re-ranking. So when they go to page 2, we know, okay, well, the theory as to why the number drops is because the first click is probably a mistake or a reflex, or the user submitted their query, they clicked on result number 1, and then they realize, oh, wait, this is not what I'm looking for. This is going to require some work. Can't just click the first result. They go back to the result set, then they start paying attention, then they go to page 2, and effectively what they've done is they've communicated a false signal about their intent. Regardless, even with that, we're still able to improve the likelihood of them clicking a result on page 2 by up to 30%. And then, as the number of